Alright, today you guys are going to be working on system substitution. This is another thing that we're doing with your PreAP class right now, where it's stuff we've already done in the past, but now we're putting it together other than just linear type functions. Okay? So I'm going to do problem number 2 for you. Alright, you're going to be responsible for the other 5. Substitution means we're going to solve for one equation for y. Now, does it always have to be y? No, it does not. It just has to be a variable that you want to choose. However, in this particular problem, the y is the best choice because there's no multiplier in front and it's a positive number. If you can find one with no multiplier in front and a positive number, that is the best one to choose. But like in system 3, which variable would you choose? Well, that's a variable, but it's a squared, so that would be tough. There's 2 variables here that are, neither one of them have a multiplier and they're both positive, so one of those might be good. That x is by itself, but it's a negative. These both have multipliers on them. Okay? So depending on how you feel about negatives or multipliers, it might be easier to choose one of these, like this x or this y. I would probably choose this y out of all of these because I don't want to have to deal with negatives if I have a choice. Okay, I would probably choose this y to solve for. Get that y all the way by itself. Okay, I'll do that for you in just a second. Let's do all of problem number 2 together. If we're solving for this y right here, we're going to add x to both sides to get y equals x plus 8. The whole purpose of substitution is because we take what we know and substitute it into the other equation. If we substitute this value for y into this other equation, we end up with x squared plus x plus 8 squared equals 34. Okay? Because that's the value that I know for y, and that's what y is squared. Okay? Then I have to say x squared plus, what is this if we take it all the way, if we square it all? Well, hopefully you remember that x plus 8 squared is the same as x plus 8 times x plus 8, not just like all one kind of deal, but x plus 8 times x plus 8. So we say x squared, here, let's write it up here, x plus 8 times x plus 8. So we say x squared plus 8x plus 8x plus 64. So we end up with is x squared plus 16x plus 64. And that equals 34. Okay? So when we're combining like terms, here we have 2x squared plus 16x plus 64 equals 34. It is a quadratic function, so we do need to solve for, or set this equation equal to 0. So in order to do that, we need to subtract 34 from both sides. 2x squared plus 16x plus 30 equals 0. Okay? Now, we're almost there. Okay? We have 2 choices here. Well, more than 2, but 2 is the most common. We can either solve with this with the quadratic formula, or we can factor it. Notice, please, that everything is divisible by 2, so it might be easier if we go ahead and divide a 2 out of every term. That divided by 2 is x squared. This divided by 2 is 8x. This divided by 2 is 15, and that divided by 2 is 0. Okay, hopefully you see now pretty easily that we can factor it. It wasn't quite as easy to see up there, but that's easy to see to factor. And that's x plus 3 and x plus 5. Okay, so if x plus 3 times x plus 5 equals 0, we need to set each one of these factors equal to 0. So x is going to equal negative 3, and x is going to equal negative 5. Now, the problem is, at this point, is that we're not finished. Okay? If it says solve, we have 2 points of intersection, right? We know that if we're solving a system of equations, we're going to get points of intersection. That's going to be our solution. We have 2 points of intersection. One has an x value of negative 3. One has an x value of negative 5. Okay? So how are we going to find the y values if we know the x values? Plug it in, right? Like those air fresheners. Excuse me. So we have negative x plus y. Negative x plus y equals 8. Right? Equals 8. Okay? So what if x is negative 3? Well, what is negative 3? Well, that's a 3. So 3 plus y equals 8. so y equals 5. So when x equals negative 3, y equals 5. What if x equals negative 5? Negative 5 plus y equals 8. So that's 5 plus y equals 8. So y equals 3. So when x is negative 5, y equals 3. Those are the 2 points of intersection. Okay? I realize that some of you could do this graphing. However, what it says is solve using substitution. So if you solve using graphing, like the discussion we had with some of you yesterday, if you solve it using the wrong directions, you're not going to get the credit. Okay? Because while you can solve it that way, that's not the way you're being asked to solve it. I need to make sure you have these skills. Okay? Let's solve problem number 3. Let's solve this equation for y, and then you'll be responsible for the rest of these. Okay? If we're solving for y, we're going to subtract 6x from both sides. And I divide everything by 3, so y is going to equal 5 minus 2x. Take the 5 minus 2x and plug it in over here for y, and go from there. Okay? You also received another worksheet today called Geometry Systems. Okay? This is the worksheet I have for you today. The system substitution is really is the topic that I need you to work on today. However, I know this is not going to take you the whole period, and I'm trying to keep you from having less homework on Monday. All right? So when you finish these, don't just sit and visit. Start on Geometry Systems. Okay? I would like you to get at least 1, 2, 3, 4, and 5. Just this first page. I would like you to get these complete. These take you very, very, very slowly through solving geometry systems, systems of equations about geometry type problems, area, perimeter, things like that. Okay? Draw a picture if you need one. Sometimes the picture is already drawn for you. Let that picture help you. Okay? But if you don't get finished with these, that's okay. All right? This is the homework page that I'm going to be checking on Monday when I return. All right? However, like I said, we're going to be working on this packet in class on Monday, and the further you are today in this pack, the less you'll have to do on Monday. All right? I hope you have a wonderful day. Please behave for Mrs. Morris. Kingston out.